Good day and welcome to the Math Salon. I'm Dr. Anumandem. For those of you new, please remember to subscribe to our channel, and if possible just click on the bell button so that you get alerts once we upload new videos. The Math Salon intends to make math as simple as we think can be for you and help you in your class examinations as well as national examinations. We always try to make sure that we use model questions that are suited to examination boards all over the world. So I encourage you, to make as much use as you can. So we are going to look at exponential functions, still in relationship with logs, because these are inverses of each other. So if we look at this, for example, the question that we see there says, find the values or a value of x that satisfy the equation this. So this question is given in terms of exponential functions here. So I have 3 to the power 2x here, 3 to the x plus 1 as power, and so forth. So in order to solve this question, I would like to remind you once more about some properties of exponential functions. We already saw before about something like a to the m times a to the n, that is a to the m plus n. A to the m divided by a to the n is a to the m minus n. So if I'm multiplying two functions like that, I can two exponential functions. If they have the same basis, then I can just add their powers. If I'm dividing two, getting a ratio, and they have the same basis, I can just subtract their powers. There are a few others that I will mention. So if I have also something like this, then I can write this as a to the m, all that to the n. So if I have a base raised to a product of two powers like that, then I can also write it as a to the 1 power, all that raised to the next power. So this is something, for example, a to the power 2 times 3 is the same as a to the power 2, all that to the power 3. And that's the same as a to the power 6. When equations are concerned, in situations where we are required to get the values of x, then if I have a certain base a to a certain function f of x, and that's equal to a to a certain function g of x, if the bases are the same, then I can just equate their powers. Then I can say that f of x is equal to g of x. So it means when you have something to solve like that, you have to try to make sure that you can arrange your left hand side to get a single exponential function and right to get a single one. If the bases are the same, then we can just equate their powers. If the bases are not the same, you can't do that, and we will see that shortly. So here I have an equation to solve, and my left hand side has 3 different terms, and they're all exponential, but this is a constant. So what I'll try to do is arrange them in such a way that I can recognize a nice form of it. Like for example, this is 3 to the power x squared. You see, we just learned here that a to the mn is a to the m, all that to the n. So I can use it here. Minus 10. We also saw a to the m plus n is the same as a to the m times a to the n. So I can write this as 3 to the power x times 3 to the power 1. See? I just showed you that there. Plus 3 to the power 4. And this is equal to 0. I noticed that I have this here, which is similar to that one. So if I want to solve this equation, you see, I only have to solve it in terms of exponential function. So to make my life simple, I will say I will write this with a simple letter like t. I can let t be equal to 3 to the power x. Then the expression will look nice and beautiful. This is a math salon. Remember, we make things beautiful. So in this case, I have here t to the power 2 minus 10 into brackets t times 3 to the power 1 plus 3 to the power 4. That is equal to 0. Of course, 3 to the power 1 is just 3. And 3 times this is 30. So this is t to the minus to the 2 minus 30 t plus 3 to the power 4. 3 to the power 4, you can just multiply that out. That's going to be 81. That's 3 times 3 is 9, times 3 is 27, 27 times 3 is 81. Once again, our idea is to factorize this, look for factors of this, such that if you sum them together, you should get the middle one. So if we do what we just did in the last video, Then I have my expression was t squared minus 30t plus 81 is equal to 0. So the factors of t are just t and t. But I have to look for factors of this. For example, 81 and 1, but it doesn't help me to get close to 30. I can take another one, maybe 27 and 3. Yeah, it looked like if you sum them, you get something like 30. The only difference is that is minus here, so I put minus on both. Minus 3 times minus 27 is positive 81. So I have two factors here then. So this factor and this factor. Remember we are doing a cross, right? But when you pick the factors, you just use the rows. So that is t minus 27 times t minus 3. So if you solve this equation, t minus 27, t minus 3 equal to 0. If two factors multiply to give 0 means either this is 0 or this is 0. So either t minus 27 is equal to 0 or t minus 3 is equal to 0. 27 can come to this side, just t is equal to 27 or t is equal to 3. But remember, it was just the idea of making it beautiful. That was not the question that we had to solve. We had put shampoo on the hair of our client in the salon. We have to wash it off. Yeah, in that case, let's put back what was there. T was actually 3 to the power x. So 3 to the power x is equal to 27 or 3 to the power x is equal to 3. We already indicated that for you to be able to equate powers, they have to get the same basis. So I will try to write 27 as something 3 raised to something. And if you check that that's 3 to the x is equal to 3 to the power 3. Or this is just to the power 1. So here, because the bases are the same, the powers must be the same. So x is equal to 3 or x is equal to 1. That's okay for that one. Let's see the second question. It says 4 raised to the power 2x plus 1 is equal to 2x minus 1. If you are given this, find the values of x. You see, once again, the bases are not the same. So one important thing, I'm glad I have only two exponential functions, one to the left, one to the right. The only problem I have is that they don't have the same basis. So I'll try to fix this. 4 can be written as 2 to the power 2. So I'm going to write this as 2 to the power 2, and I keep the power there, the 2x plus 1. I just fix only this part, and that's equal to 2 to the x minus 1. But we also saw 2 to a power, and another power is just 2 to the product of that. So this is 2 to the power 2 times 2x plus 1, and that's equal to 2 to the x minus 1. Now that we have the same basis, the powers must be the same. So 2 to 2x plus 1 should be equal to x minus 1. You can open this nicely. 2 times 2x is 4x. 2 times 1 is 2. And that's equal to x minus 1. It's important to solve for x that we carry everything to our left-hand side. So for example, this x, if it comes here, it becomes 4x minus x. I take this 2 this way. This minus 1 minus 2. So if you check that well, 4x minus x is 3x. And that's equal to minus 3. So here x is equal to minus 1. We go to the last question here. Given this 2, show that this is true. Given that 2 to the power x is equal to 3 to the power y, and that x plus y is equal to 1, show that x is equal to the log of 3, of course, to the base 10. We normally don't write it. And log of 6 to the base 10. Notice from here, these two are not the same basis, so I cannot equate their powers. I can't do that. And there's no way I can express 3 here as a multiple in order to get 2. It's not, we don't have that. So we have to think alternatively. But luckily, we are given a relationship between x and y. So it means I can replace the y here. To do that, if x is this, since we know that x plus y is equal to 1, then y is equal to 1 minus x. So I can write this as my 2 to the power x, 3 to the power, instead of the y, I replace it with 1 minus x. When our bases are not the same, we have to think about the relationship between exponential and log. So what I'll do is I'm going to take log to the base 10 of both sides of this. So what I'll do is I'll take log, I will not write any base because we all know it's 10, is equal to the log of this. Also, I won't put anything there. But the question, why do I do that? Because this is the only way I can remove those powers using the properties of log. I already showed you in the previous video that log a to the power n is n multiplied by log a. So my x can fall in front, and I get log 2 is equal to, this one falls in front, 1 minus x log 3. I'll try to open this to make it nice. That is 1 times log 3, so that's just log 3 minus x log 3. I take my x's to my left hand side, so this can come this way. So I get x log 2 minus 3, x log 3, and that is equal to log 3. So now we also saw the issue about, I can factorize my x here. I have x and x there. So this x here into log of 2 minus, this should be plus. It was minus, if it becomes plus. When we add two logs, it's just the product of their values here, the arguments there. So my x is equal to the log of 2 times 3. And that's equal to log 3. Now to solve for x alone, I just have to divide both sides. 2 times 3 is 6. So my x is simply equal to log of 3 divided by log of 6. This is 6 here. So if I divide both sides by log 6, this is log 6, this goes off, and x is equal to that. Hope it was helpful. Please give us some thumbs up. Remember to subscribe, share with your friends. Most importantly, watch in groups and discuss. That makes you better prepared for your examination. Bye.